Good day to one and all. I am T. Arun Kumar from the team Supernova. We all live on Earth, the third planet of the solar system, and the only planet that supports life. It is covered with wonderful plants, trees, oceans, hills, deserts, and many more. Just take a moment to look around. These are commonly named as materials. Yet another astonishing fact is that all these are made up of millions and millions of atoms. So, it is very important to learn how atoms are structurized in a unit cell. Atoms basically form 14 types of lattices. These are mainly called as Bravais lattices. Now, my group members will explain each Bravais lattice with their voiceovers.
The first one we'll be seeing is the primitive cubic cell or the simple cubic cell. The primitive cubic system consists of one lattice point on each corner of the cube. Each atom at a lattice point is then equally shared between 8 adjacent cubes, and the unit cell therefore contains in total one atom. The edge length in the simple cubic cell is always the same. The internal angle between the edge length is always maintained at 90 degrees. The coordination number of the simple cubic cell is 6, and the number of atoms per unit cell remains 1. The packing fraction of the primitive cubic cell is 1/8 of the atom.
The body-centered cubic system has one lattice point in the center of the unit cell, in addition to 8 corner points. The body-centered cubic unit cell has atoms at each of the 8 corners of a cube, like the cubic unit cell, plus one atom in the center of the cube. Each of the corner atoms is the corner of another cube. So the corner atoms are shared among 8 unit cells. It is said to have a coordination number of 8. The body-centered cubic unit cell has a packing factor of 0.68. That is, it has 68% packing efficiency. Some of the materials that have a body-centered cubic structure include lithium, sodium, alpha iron, and tungsten.
The face-centered cubic unit cell is one of the lattice structures where metals tend to structurize to a maximum extent The unit cell dimensions A, B, C are equal to each other, whereas the interaxial angles alpha, beta and gamma are all equal to 90 degrees. Due to the sharing of atoms, 1/8 of 8 corner atoms and half of 6 face-centered atoms add up to 4 atoms per unit cell. The coordination number is 12 and the packing efficiency is 74%. Some elements that follow this structure are helium, neon, aluminium, calcium and etc.
This is Maniganan. I am here to explain about the crystal structure of a simple tetragonal unit cell. This is formed by extending a simple cube along a single lattice vector. All lattice vectors are inclined at equal angle to each other. Therefore, alpha is equal to beta is equal to gamma is equal to 90 degrees. All the three sides are not equal. A is equal to B, but A and B are not equal to C. All the four corners are occupied by a single atom. That atom shares 1/8 of its total volume to that unit cell. Hence, calculating, we get that only half of an atom exists in this simple tetragonal unit cell. Thank you.
The tetragonal lattice results from stretching a cube lattice along one of its lattice vectors so that the cube becomes a rectangular prism with a square base. Now the lattice has the following dimensions: A equal to B and not equal to C. The interaction angles of the lattice are all equal to 90 degrees. It has 8 atoms in the corners and all the 8 atoms contribute 1 by 8th of its volume, 1 in the center of the intersection of the body diagonals. A famous element which shows this body-centered tetragonal cubic is silicon.
The primitive orthorhombic lattice is a cubic lattice that has been stretched or compressed so that the lattice constant in the three basic directions are all different. Simple or primitive orthorhombic lattice has one lattice point at each of the corner of unit and interaxial angle, that is alpha, beta and gamma, are all equal to 90 degrees. And the example of simple or primitive orthorhombic lattice is neptunium.
Base-centered orthorhombic lattice is basically a rectangular prism and like all lattices has lattice points at the 8 corners of the unit cell plus additional points at the centers of two parallel sides of the unit cell. It has unit cell vectors A, B and C. In this case, the interaxial angles is found to be 90 degrees. The elements which exhibit this kind of lattice are chlorine, gallium and iodine.
Hello viewers, I am going to make yourself brush up on the topic body-centered orthorhombic unit cell. In a body-centered orthorhombic unit cell, the length, breadth and height in this unit cell are not always equal, which means A is not equivalent to B and B is not equivalent to C. The angles made by the sides of this unit cell are always equivalent to 90 degrees, which means alpha is equivalent to beta and beta is equivalent to gamma, which is equivalent to 90 degrees. In this unit cell, there are atoms at all the 8 corners and one atom at the center of the unit cell itself. The atoms which are at the corner are shared by 8 other neighboring unit cells, and the one which is at the center of the unit cell is left unshared. As a result, each body-centered orthorhombic unit cell has 2 atoms with it.
Face-centered orthorhombic lattice, like all lattices, has lattice points at the 8 corners of the unit cell plus additional points at the centers of each face of the unit cell. It has unit cell vectors A, B and C which represent length, width, and height respectively, and in this case, the length, width, and the height of the unit cell are all unequal to each other. The interaxial angles, namely alpha, beta, and gamma, are all equal to 90 degrees. Only sulfur exhibits face-centered orthorhombic lattice structure.
Rhombohedral unit cell consists of 8 atoms, all at the corner of the cubic system. Each atom represents 1/8 part of its atom, thus making total 1 atom in the unit cell structure. It is stretched along its diagonal, giving it a rhombohedral figure. It has 3 sides, A, B, and C, with A equals to B equals to C, and each side has its different angle, that is alpha equals to beta equals to gamma, which is not equals to 90. These type of unit cell structure we can notice in lithium at 4.2 K.
Monoclinic system. One of the structural categories to which crystalline solids can be assigned. Crystals in this system are referred to 3 axes of unequal lengths, namely A, B, and C, of which A is perpendicular to B and C, but B and C are not perpendicular to each other. The monoclinic unit cell is distinguished by a single axis called an axis of twofold symmetry, about which the cell can be rotated by 180 degree without changing its appearance. More solids belong to the monoclinic system than to any other. So, for a crystal to be monoclinic, it has to have either one or twofold axis, one mirror plane, or one or twofold axis with a mirror plane perpendicular to it.
Base-centered or side-centered or end-centered monoclinic lattice, also known as monoclinic C, like all lattices, has lattice points at the 8 corners of the unit cell, plus additional points at the centers of 2 parallel sides of the unit cell. It has unit cell vectors A not equals to B not equals to C, and interaxial angles alpha equals to gamma, which is equals to 90 degree, and not equals to beta.
The last one we are going to see in crystallography is the hexagonal crystal family, which is one of the 6 crystal families. In the hexagonal crystal family, the crystal is conventionally described by a right rhombic prism unit cell with 2 axes and an included angle of 120 degrees, which is gamma, and an height of C, where C can be different from A and perpendicular to the base axis. There are 12 groups associated with it, which are exactly those whose Bravais lattice is either hexagonal or rhombohedral. The hexagonal crystal family consists of 2 lattice systems, which is hexagonal and rhombohedral. Each lattice consists of Bravais, which one of Bravais lattice, and the example of this is quartz and beryl.
Primitive triclinic unit cell. Primitive cell is also known as a simple unit cell. In a crystal lattice, the lengths are denoted by A, B, and C, and whereas the angles are denoted by alpha, beta, and gamma between the transition vectors. In triclinic unit cell, A not equal to B not equal to C, and alpha not equal to beta and not equal to gamma. That is, all the edges and the angles are unequal. In a primitive triclinic unit cell, the total number of atoms is 1, where each of the corner parts of the unit cell contribute 1/8 part of the unit cell. Potassium trichromate, copper sulfate, and boric acid shows this type of crystal lattice formation.